Hello and welcome to Cat Bytes, where we will discuss some topics which are important for aptitude exams such as the Common Admission Test for IIMs in India. Of course, these topics are not only relevant for CAT but for most other exams which test your quantitative, reasoning and language aptitude. I am an engineer from IIT and an IIM graduate with a passion for learning and teaching. And I hope that by watching this series, you too will see how simple, useful, and fun these topics can be. My approach would be to provide you examples so that it is easier for you to commit concepts to memory and also show you how to tackle difficult questions. These exams make you think, and there will be no one to help you in the exam hall. Therefore, it is very important that you gain the confidence of problem solving by understanding the theory and tricks, rather than just give up and look at solutions. So, let's begin. One of the key topics that I see people struggle with is logarithms. But this is important to master because CAT usually has several questions on this topic. In this video, we will start off by discussing the basic concepts and formulae of logarithms. After gaining a fair understanding, we will proceed to problem solving by considering a few questions that appeared in 2018 and 2019. Then I'll present a summary of the main concepts. Let's now see what this is all about. So, what are logarithms? I hope many of you would be familiar with powers or exponents. If there are three numbers a, x and y and x is equal to a raised to the power y, we can express the same relationship in the form of logarithms. We will say that the logarithm or log of x with base a is equal to y. So, logarithm is a way of expressing the relationship between three numbers. When you say log of something, say x, to some base a, it basically tells you to what power must a be raised to get to x. Since 2 to the power 3 is 8, we can say that log of 8 to the base 2 will be 3. Now, when we work with logarithms, we are also bound by certain constraints. The first is that the base a has to be a positive number, but not equal to 1. If a was negative, the function would be extremely complicated as odd and even powers of negative numbers are negative or positive. Also, if a was 1, all powers of a would also be 1 and we will not have anything meaningful to express using logarithms. The next point to note is that x will also be a positive number. Think about it. Can you get a negative number by raising a positive number to any power, positive or negative? The answer is no. So you cannot get a negative number by raising 2 to a negative power. Only a number which is less than 1. 2 to the power minus 1 is 1 by 2 or 0.5. 2 to the power minus 1000 is also a positive number, although much smaller than 1. But there is no such restriction on what the power or y could be, as you can see from the graphs on the right, where I have plotted log of x to three different bases 2, 5 and 10. The power can be any positive or negative value. Also, talking about the graphs, all the three pass through the same point 1, 0 on the xy plane. Why that happens will become clear in a bit. Also, notice that the larger the base is, the flatter the graph of log x is. Another point which should be clear is that log a to the base a is 1. Since you can get a by raising it to the power of 1. Lastly, to round up the introductory discussion, if there is no mention of a base, it usually means it is 10. Also, ln of x is written when the base is the Euler's number e, and it's called natural logarithm. Now, let's discuss some interesting properties of logarithms. The first is that log of the product of x and y is log of x plus log of y. It is easy to see and memorize this with an example. If x were to be 4, which is 2 raised to the power of 2, and y were to be 8, which is 2 to the power of 3, we will get log base 2 of 4 times 8 as log base 2 of 32, which is 5. You'll also get the same number 5 if you were to add log base 2 of 4, which is 2, and log of 8, which is 3. Moving on to the next property, which is log of x divided by y is log of x minus log of y. Like last time, let's consider the example of 8 and 4. Log base 2 of 8 divided by 4 is log of 2, which is 1. You can also get the same value by subtracting log of 4 from log of 8. Another interesting consequence of this property is that log of 1, whatever the base may be, will always be 0. Recall the graphs that we saw earlier. Hope it's now clear why all the graphs pass through the point 1, 0 on the xy plane. Now let's talk about another interesting property, which is log of x to the power m is m multiplied by log of x. In the example we have shown, the base is 2, x is 4, and m is 3. So, if we take log of 4 cube with base 2, we get log of 64, which is same as 3 times log of 4. For the smarter amongst you, we can also derive this property by thinking of x to the power m as x multiplied by itself m times. So, log of x times x times x and so on will be log of x plus log of x plus log x and so on. I'll pause for a moment while you work it out. Now for the final set of properties. Log of x with base y can be written as log of x with some base a divided by log of y with the same base a. Remember, we can choose any base, but it has to be the same base in the numerator and denominator. This is often known as the change of base rule. Once again, this formula can be understood by taking x to be 64 and y to be 4. Log 64 with the base 4 is 3, which you can also get by dividing log of 64 with base 2 and log of 4. The last property which we can derive from this discussion is that log of x to the base a is the inverse of log of a to the base x. Keeping these concepts in mind, we are now ready to solve some problems which appeared in CAT 2018 and 2019. So hope you're excited for the more interesting part of this video. The first one is from CAT 2018 and a relatively easy question compared with others which can be quite tricky. Here, all you need to know really is the meaning of logarithms. Well, you'll see for yourself. Why don't you pause to attempt this yourself and continue when you're ready. So, if you're ready, let's look at how to solve this question. We are asked the value of a plus b, where a is present in the first equation while the second contains both a and b. Let's try to find a from the first equation. Basically, the first equation is saying that 5 plus log of a to base 3 is equal to 2 to the power of 3, which is 8. Solving further, you get log of a is 3 and therefore a is 3 cubed or 27. Moving to equation 2 to find the other variable b. This equation is basically saying that the sum of 4a plus 12 plus log of b to base 2 is 5 cubed, which is 125. You can use the value of a, which we have already derived, and then simplify to get log of b as 5, and therefore b would be 2 to the power 5, which is 32. And therefore a plus b will be 59, which is option 4. This one is slightly more difficult problem from the same test. We need to solve for x. We can start by taking log of both sides using base 2. But before I go any further, I'll encourage you to try completing the solution. Once you're ready, continue to watch how I would solve it. Okay, so as I said, let's take log on both sides. On the left hand side, we get x, and on the right hand side, we will get log of 3 to the power log 2, which can be written as log 2 multiplied by log 3. Now comes the interesting bit. We have found one way to write the value of x, but this does not match with any of the options. Maybe we need to write the answer in a different form, but what form? If you look closely, 3 of the 4 options are in terms of log with base 5. If we convert our earlier expression to base 5, we get x equal to log of 3 to the base 5. Unfortunately, this still doesn't match any option. But don't worry, we are getting closer to the answer. Upon looking at options again, 2 and 4 are eliminated since log 3 is definitely not equal to log 8 or log 9. But what about option 3? If we simplify option 3, we will in fact see that it is equal to log 3 to the base 5, and so we get our answer. Remember, these questions are designed to be tricky, so don't get frustrated. Just have confidence that you know the subject and keep trying. Now let's tackle an even harder problem from the same test. We are told what p is and then asked to compute the value of an expression involving p. As before, please try to solve this yourself before watching the solution. Let's start with the easiest approach that comes to our mind when we see this, and I think that would be to substitute p in the expression. Remember, our aim is to reduce the number of terms since all the options have only one term. Therefore, to simplify the expression and reduce the number of terms, we write 4 as log of 12 to the power 4 with base 12. We now get a simpler expression, but it still looks very different from all the options available. Don't worry and think calmly. If you look at the options, 2 out of 4 have a base of 6. So what if you try to convert the earlier expression to base 6? We first use the change of base rule and then simplify by breaking 12 into 6 and 2 and writing 81 as 3 to the power 4. It takes a few more steps, but eventually we simplify the expression to the form of log 8 to the base 6, which is option 2. Again, as I mentioned in the solution to the previous problem, don't lose heart and don't be afraid. Have confidence, keep trying, and you will get to the answer. This is what will set you apart from others who will stop trying to solve this question because it looks difficult. Now let's consider a problem from CAT 2019. I think this one is much simpler compared to the last one, but you may disagree. Why don't you pause to try this question and see if it is actually easier? Okay, let's start by simplifying the first equation. We use a few concepts that we have learned and eventually derive that x squared minus y squared should be 125. Moving to the second equation, upon simplification we get y is equal to 2/3 of x. You can substitute y in the earlier equation and we get x equal to 15. From this value of x we can then get y equal to 10 and x times y as 150. So option 4 is correct. Wasn't so difficult after all, was it? Let's wrap up this session by recalling the key concepts we have learned. Remember, these concepts are enough to solve almost all the questions you will face. Hope you found this video useful and feel more confident about tackling problems related to logarithms. If you did, please hit like and share with your friends to show your support. I'll make more videos on such topics, so stay tuned. And until that time, keep learning and growing. Thank you.